Okay, so in lesson 11, we're going to look at reading expressions in which letters stand for numbers. So the opening exercise asks us to complete the graphic organizers with mathematical words that indicate each operation. So we're just looking for those words that we would refer to as keywords that tell us when we're using a certain operation. In class, we've come up with a list. And I'm just going to write some of these words down. You may have more from class that we also put down. So for addition, some of the words we would use there are plus, sum, which is the answer to an addition problem, add, more than, and increased by. All these words tell us that we are going to be adding. So for subtraction, some words we use are difference, which is the answer to a subtraction problem, minus, less than, subtract, and decreased by. All subtraction words. For multiplication, it would be product. That's the answer to a multiplication problem. Times, twice, which means times 2. Triple, which means times 3. Multiplied by. Or sometimes with fractions, you may see fraction of. So for example, if I see half of, that would mean 1/2 times something. For division, quotient, which is the answer to a division problem. Split equally or evenly. Or anything in that same idea, or divided. For exponents, squared means an exponent of 2. Cubed means an exponent of 3. And you might see to the whatever power, so to the 4th power, 5th power, whatever, so to the something power. So these are all some words that we may see in today's lesson. So we're going to be given some verbal statements, and what we're going to do is rewrite them using numbers and variables. Okay, so on your paper you have a table. In the first column, it's giving us the verbal statement. It wants us to underline keywords and write operations that those keywords are showing us. Then we're going to write it algebraically, so that means we're going to put it with numbers and variables, and then we're going to see if we've actually followed the order of operations when we rewrote it as an algebraic expression. So looking at the first one, it says the sum of twice b and 5. So the keywords that I see are sum, which means I'll be adding, twice b, which means I'll be doing 2 times b, and then I'm adding that 5 with it. So the sum of twice b and 5 means I'm going to do twice b added to 5. Now, order of operations would tell me that I would be multiplying first here. So it doesn't really matter if I do 2b plus 5 or 5 plus 2b, because in either case, I'm still going to do the multiplication first, just because order of operations tells me to do that. So this one, I really wouldn't need parentheses around it in order to see that I'm doing that first. So I am following the order of operations there. The next one says the quotient of C and D. Quotient is the answer to a division problem. When it's written like this, it's telling us the order in which we're dividing. So if it says the quotient of C and D, that means in that order we're dividing. So C divided by D. C divided by D. we can use the division symbol. More likely, we're going to see it written as C over D. That fraction bar, remember, means divided by, so C divided by D. There's only one operation here, so we did follow the order of operations. The next one says A raised to the 5th power and then increased by the product of 5 and C. So this is an exponent raised to something power, in this case the 5th, so we'll be using an exponent of 5. And then increased means we're adding by the product of 5 and C. Product is multiplication, so that means we'll be multiplying 5 and C. So if we look at this, we have A raised to the 5th power, so A to the 5th power, then increased by the product of 5 and C. With this one, to see if we're following the order of operations, we would want to see if we're following what it says. So it says to do A raised to the 5th power and then increase it by the product of 5 and C. Within this problem, because of the order of operations, we would be doing the exponent first. Exponents come before addition or multiplication. So it would be fine the way we have it. We can also flip it and do 5C plus A to the 5th power. Because of that order of operations, we would still be doing A to the 5th power first, no matter if it was written this way or that way. Okay, so the next one has a word in it that we haven't talked about, and it says the quantity of A plus B divided by 4. When we see quantity, this is going to tell us that we're going to put parentheses around what's coming next. So this is the quantity of A plus B, so plus is addition, divided by 4. So that's saying put parentheses around A plus B, so we'll be doing that first, and then dividing that by 4. So if I didn't have the parentheses around A plus B, and I'm dividing it by 4, it means I would be doing the B divided by 4 first. So we really need that parentheses around to make sure we're getting that quantity first and then dividing by 4. We can also write it using that fraction instead. So because we put those parentheses in, we are following the order of operations. The next one says 10 less than the product of 15 and C. Less than tells me I'm going to be subtracting. Now what's really important here is when it gives you a number less than, that means minus that number. So 10 less than means minus 10. This is really important because there is no commutative property with subtraction. So 10 less than does not mean 10 minus what comes next. It means whatever comes next minus 10. So that's something I really want you to remember. Product means multiply, so that means I'm going to be multiplying 15 and C. So if it says 10 less than, order does matter. I have to do 15 times C, which I'll just write as 15C minus 10. And I can't switch the order. I cannot do 10 minus 15C because that would be a different answer. Since we followed that 10 less than, this is the order of operations. The next one says 5 times D, times is multiplication, and then increased by 8. So 5 times D is 5D, increase it by 8. With this one, again, order does not matter because regardless, even though it says and then, I would still be doing 5D first because multiplication comes before addition. So I could write it 8 plus 5D. Still multiplying first and then increasing by 8. Okay, so the next one, 15 divided by, is just division. The product of 2 and R. This one, order will also matter because I have to make sure division is in the correct order because there is no commutative property for division. So if it says 15 divided by, that means I need to do 15 divided by, then whatever it says. So if I do the product of 2 and r, that means 2 times r, but product is an answer word. So that means I want to do 15 divided by what I get from this problem. So in this case, I would want to put the 2 times r in parentheses. If I didn't have it, it could look something like this, 15 divided by 2 times r. And in this case, I would do the 15 divided by 2 first, and I don't want to do that. So that's why I'm going to put the parentheses around the 2 times r to show that I want to do that first and take the product from it and divide 15 by that product. I can also write this with the fraction bar as well. It's not going to change my order, so I am still following the order of operations. 25 decreased by the sum of g and 3. Decreased by, this is different from the subtraction problem before. If I'm taking a number and decreasing it by something, that means I'm taking the number and subtracting it by whatever I have. So it says 25 decreased by the sum, which is addition, of g and 3. Now again, if I were to write it like this, I would be doing 25 minus g first, but I want the sum or the answer to g plus 3 first, so I would need that in parentheses. So it would be 25 minus the sum of g plus 3. A lot of times these answer words tell us that we're going to want parentheses around it. Not always, but sometimes. We can't flip the order on that one either because it is subtraction, no commutative property. It has to be 25 minus that sum. So the next one says Marcus has 4 more dollars than Yassine, and Yassine is being represented by the letter Y. So more means I'm adding, so I'm going to take 4 and add it to Yassine. I can also write this as y plus 4. It's only one operation, and it is commutative, so it doesn't matter which order we write it in. The next one says Mario is missing half of his assignments. Now, we have half of. This is a fraction of, which if you recall from the beginning with our keywords, we said meant multiplied. So that means I can take 1/2 and multiply it by the variable a, and that would just be written as 1/2 a. Another way that you can split something in half is to divide it by 2. So I can take the number of assignments and divide it by 2. Either one of these show the same thing. If we say half of something, we can multiply it by 1/2 or divide it by 2. Both are just one operation, so it's following the order of operations.